Okay, now that more or less concludes our vintage analysis component of today's program. But now what we're going to do is get into a panel discussion which focuses on artificial intelligence in agriculture and particularly in wine growing. And the idea of this panel came to me because 2019 was a very good year for me. I got to travel a lot around the world and see various different wine growing regions. And what I learned is that we here in Napa really have all of the technology that we need at our fingertips. And moreover, this region is very good at collecting data. And what we're about to see in the coming years is a coming revolution, really, of computer science. What our abilities are in terms of analyzing data and creating predictive outcomes. So in order to assemble this panel, I called up my friend Luca Brillante, and I asked him what exactly we should do, which topics we should go over, and he said, you called the right person, because this is my forte. So we get to now hear a little bit of introduction about what artificial intelligence actually is and how it's been used in wine growing or in viticulture throughout. So if you'll please welcome Luca Brillante.
Thank you, Mark. Thank you, everybody, for joining us. Actually, all the work will be done by the panelists. I'm here just to introduce the topic and make questions. I would like to start by speaking of AI and telling you that it's not a very recent thing. It actually started maybe after the Second World War, and the idea was trying with the development of computer. The persons always had the idea of say, can we try to make this computer doing our harder work, which is in some way try to think for us and solve our most common problem. And so this developed the artificial intelligence kind of concept and field in computer science. And the current state of the art of the artificial intelligence, at least to my opinion and to many others, is the use of machine learning and specifically of deep learning. So machine learning is a subset of artificial intelligence, and just try to give the machines the opportunity of learning from the data in order to take the most important patterns and formulate predictions. Deep learning is a subset of machine learning and is related to the use of machines for tuning deep neural network in order to do the same thing, which is trying to predict the future. We have been hearing a lot about these technologies, and that's why when we speak of emerging technologies, I would like to let you aware that there is pretty much a path that all new technologies go through in the development all the way to the production. And this is called an hype cycle, and starts with the innovation triggers, basically research and development from the universities or the industry can start developing a new technologies that has potential for being very innovative and changing the way we actually do our work. And this rapidly it builds up, if it's successful in the first cases, a success history that builds up a hype. And we arrive at a peak of inflated expectations, which is, we think this technology will solve our life, and instead, of course, we are not there yet. And we are just starting to understand how we can use that in order to actually simplify our work. And so our expectation get disappointed, and we go through a dip, which is a true of disillusionment, toward which, if the technology is strong enough, we actually understand how to use it and bring it to a production kind of asset. And where do you think machine learning is at this point? Is most likely on the top of the peak. So, which is not a bad thing, because we are here in a viticulture meeting speaking about what we can do with this technology. And it's only if we consider as an industry that this technology is worthwhile that we'll pass through that dip and we'll make sense of that technology in our common work. So in the end, machine learning is a form of an hybrid between statistics and computer science. And I will just make a comparison between how we normally model agricultural systems in order to differentiate with what machine learning eventually is for the main characteristics. So we generally, not much in viticulture, but mostly in cereals or in large crop, we use a lot of mechanistic models to actually formulate how the environment affects the plant performances, and if there is a change in the environmental characteristics, such as the VPD, we will have that response on the plant. And so this is very strong theoretical background, while machine learning in the end does not have a strong theoretical background in the biology of the thing, but instead try to learn from the data. And in some way, it's a form of empirical model where you collect the data first and then you analyze them, instead of saying, oh, these data should fit this assumption about the biology of the plant. And so we describe first in a mechanistic model the biology, and then we fit our mechanistic functions, while in machine learning, we interpret the models after the fitting. So the mechanistic model tries to impose a suitable shape that is related to what are our knowledge in biology at the current moment, while the machine learning tries to learn from the data that are available. The mechanistic model is obliged to simplify the reality because we don't know everything about all the biological world. And so we just are obliged to respect what are our current knowledge about this biological phenomenon and then predict from that. While in machine learning, the prediction is not theoretically backed up by a biological framework. It's just a computational algorithm that has its own performances. The problem of mechanistic models is that with the effort of understanding all the different parts, it loses a lot of power in prediction, while machine learning, the reason why it's so successful and so used across the technology work is because it's very, very powerful in predicting future conditions. So we are basically at this point trying to figure out how the viticulture can make use of this new technology that just landed in our field. And I'll just show you a couple possibilities. So machine learning technology has been able to develop maps of soil water in space under grapevines in 2 dimensions or in 3 dimensions. Has been able to be used for prediction of yield, and this was a project that was run while I was working at UC Davis for the Efficient Vineyard project, and this was developed by our collaborator at the Carnegie Mellon Institute. This is a machine vision technologies that actually counts all the berries on the fields and try to estimate the yield and mapping the yield. At the same time, in wine grapes, we had some problems, especially in the Central Valley, because the grapes are covered up. But our table grapes collaborators were very happy because not only they can estimate because you see the grapes more easily, but they can also see if they can pick the grape at the right time if they are covered enough. And so those simplify their work. If instead of a camera as the ones, an RGB camera as the one in the previous work, you substitute with an hyperspectral camera, you can imagine to estimate color and sugar composition on the go in the same way. And recent work from Australia is trying to see how much spoke exposure these grapes get in order to make selective picking on the vineyard and save from bringing that up into the winery. So at this point, my introduction is complete. I would like to introduce our speaker that will tell us where are we going next, and most likely is not the use of deepfake as in this case. Okay, thank you very much.